we have sigma an. So let's say here an is n squared plus 1 over n times 2n. By the way, 2 raised to n, this exponential factor grows faster than n squared, so an is going to go 0 when n goes to infinity. That means we cannot apply the test for divergence and conclude this diverges. This might diverge or converge, we don't know. Okay, so 2 to the n, we have n squared plus 1. Limit comparison test is difficult. Let's use the ratio test. Okay, this is an, then an plus 1. The next term would be just replace n throughout by n plus 1. So n plus 1 quantity squared plus 1 over n plus 1 2 raised to n plus 1. All the terms are positive, so we don't need absolute value when we are using the ratio test. Now limit n goes to infinity of, let me write ratio test. Okay, I'm using ratio test over an is equal to limit n goes to infinity. Absolute value we don't need because all the terms are positive. An plus 1, this fraction divided by an. Okay, so we got n plus 1 squared plus 1 divided by n plus 1 times 2 raised to n plus 1 divided by this fraction, which is same as multiply by its reciprocal. So n 2n on the top over n squared plus 1, and we don't need absolute value. Let's evaluate this limit. Limit n goes to infinity of, okay, here's 2n, 2 raised to n plus 1. We can factor 2 raised to n plus 1 as 2 raised to n times 2 raised to 1, which is 2. How does this help? Then we can cancel 2n and 2n. Okay, now let's write in this way. Then what is left? N times quantity, in fact n plus 1 quantity squared plus 1 on the top. Okay, 2 raised to n times 2 raised to 1. 2 raised to n, 2 raised to n cancel, so we have 2 raised to 1 just 2. 2 times quantity n plus 1 and times quantity n is squared plus 1. Now we have a polynomial on the top, a polynomial kind of polynomial on the bottom. Okay, let's find the limit. Limit n goes to infinity. Since n goes to infinity, the limit is same as the limit of the leading terms. So what is the leading term on the top? When we expand n plus 1 is squared, that means multiply n plus 1 by itself, you get n is squared plus other smaller terms. So n is squared, and when we multiply by n, it will be n cubed. So n cubed is the leading term on the top over, same here, n is squared, n cubed, and we get a smaller term and multiply by 2. So 2n cubed is the leading term. Okay, these two ratios are not the same, but their limit when n goes to infinity are same. Okay, that is same as n cubed cancel 1/2, and 1/2 is less than 1. Then by the ratio test, the series converges absolutely, but this is all positive, so converges. Okay, then by the ratio test, because this limit is less than 1, the series converges.